So hello also, as the today's agenda is just for the logistic regression, you have to understand that what is logistic regression. So before that, I want to just share you the few things within fast track. We can say that is the introduction, that is the data science, that what is the need of data science, life cycle of the data science, applications of the data science, introduction to R and introduction to RStudio. So this is just like that in the previous seminar also, previous webinar also, we have taken these things, and because the new people are joining, so definitely we have taken this as a fast track. So very first that you know about the data right now, the 10 years back data format is a little bit different kind of things, and today is very different scenario. It's a lot of use of data is generated in the social media itself, also in Twitter, also Facebook also, and there are a lot of variety of data. That is unstructured data, multiple formats you are having a data. You are having a data in JSON format, you are having a data in XML format, in PDF format, JPEG format. A lot of formats are there. So you are having a variety of the data, and for that you have to the need are to understand and analyze data to make better decisions is what give the birth to the data science, you can say. So this is the need of data science, that how you are taking the decision on the basis of your data is very important, and that's why the need of data science is generated, you can say. So in that case you just understand the data, and after that you find the interesting insight from your data, and then you are finding out the make informed decision according to the on the basis of that one. So first you are just like pulling the data from the various data sources, then you are understanding your data, you are making a data warehouse kind of things, and then after that you are finding interesting insight from your data, and you just take the on the basis of that you are making informed decisions on that. So what do you mean by the data science? That basically you can say applying science on a data to make a data, just like talk to us, like that is your data science. So data plus science is equal to data science, you can say. There are a lot of just like you can say in data science is in umbrella in which you can say encompasses the multiple domains. Basically in that scenario you can data visualize, then you have to be a data manipulation, then you have to do the statistical analysis, and then you learn the machine learning kind of the things. This is generally you can say the process for the data science, you can say, and you are just like doing this kind of thing. So lot of tools are available for using this one, just like you are having a top of the level. There is a R, that is a statistical language, and there is a Python also used for the data science. There are so many tools are also available for the visualization. Microsoft Power BI is there, Tableau is there, ClickView is there, MicroStrategy is there. Lot of tools are available. So that is up to you that which type of the tools are you are using for the visualization purpose, and which language you want to use for the different kind of the analytics you want to do. So in data type you can say there are the different kind of the data analytics also, like that there is a prescriptive analytics, predictive analytics, and the descriptive analytics also. So in prescriptive analytics, basically enabling smart decisions on the basis of your data, that is you are known as the prescriptive analytics. And the very easy example for that one, and that when you are just like booking your tickets on the flights, the every hour the flight rates are changing on the basis of your real time data. So that is known as the example of the prescriptive kind of analytics. There will be predictive analytics also, in which predicting the future based on the historical pattern of your data, and just like on the basis of your previous data or the historical data, you will predict something. And there will be another kind of there that is a descriptive kind of the analytics, in which you are mining the data to provide your business insights. That is known as descriptive analytics. And a lot of examples like that, the Amazon Prime is there, YouTube is there, Netflix is there, like that kind of thing, they are doing descriptive kind of the analytics. That's the example of you can say descriptive analytics. While you are watching certain kind of the movie or watching some kind of the serial, and they are suggesting on the basis of that real time, they are suggesting you a movie or the serial, that kind of this stuff. So this is just for the understanding purpose. And then you have to just like in the our scenario, we are using R as a programming language and introduction to RStudio also. So you have to install the R in that one, and then you have to install the RStudio also. That is the key thing for installing the things. Then this is your main agenda, that today we want to learn the logistic regression. So before logistic regression, definitely you have to understanding the different kind of the classifications, and in the classification you have to learn the introduction to logistic regression. Then what is logistic regression, then why logistic regression, then logistic regression applications, a spam email classifier, like that it is example, simple example for that one. And you can say demo on logistic regression using R language, that how we are creating a model from R. So that is the case. So very first we have to, this is a kind of supervised learning, you can say the classification comes under supervised learning. So there are two type of the main learning, that is supervised learning and unsupervised learning. So just like I can explain you that what do you mean by the classification. Classification is a process of grouping the things according to similar features they share. So just like in the example itself, it is graphically represented that everything which is related, just like there is a beans. So in which one bean there is a paper, in another bean there is a metal, another bean there is a plastic, another bean there is a e-waste, or another bean glass, and another thing is the organic kind of thing. So these are just like grouped, you are grouping something, and that grouping is just like you are doing the classification kind of the thing. And on the according to that you are just like predicting something, that is the case. So basically when just like in the supervised learning, you are seeing that there will be data will be available in the two types. One is continuous kind of the data, in which just like you are having a sales figure on the basis of last 3 year, the sale value of the gold, for example, or in the day basis you are having a value of gold. So that is just like the predicting, on the basis of that you are predicting the price of the gold for the next 3 months or the next 6 months on the basis of your previous data which you are having. So it is a kind of example of the linear regression. So linear regression means the data is in the continuous value you are having, and on the basis of that you are finding generating the linear regression, that is a y is equal to mx plus c kind of thing. That is a straight line for the linear regression. And on the basis of your dependent data and independent data, you are predicting certain kind of things that will be benefited for the, just like finding out the sales value, or the kind of e-commerce industry, you can find out the value of the product on the basis of that, or share market prediction of that also, that is the case. And in categorical, there is a classification in which just like you are having a 0 or 1 kind of data, or you are having the another things might be possible, that yes or no kind of data, or the true or bad kind of the data, that is the case. So in the last also, I just want to say share you some application of the data science in the different industry, or we can say in the, just like in our scenario we are taking example of the telecom industry. So in telecom industry, you have to find out the analytical customer relationship management also. You want to find out the fraud reduction might be possible. You want to find out the bad debt reduction also, might be price optimization. Why it is told supervised analysis. Supervised, there are the two type of analysis basically. One is supervised learning and another is unsupervised. Supervised learning means just the way you are giving the training to your data. It means you are training your data, and on the basis of your training data you are predicting something. Just like I am guiding you, for example, so and you are learning something. So this is the example of supervised learning. And another example is unsupervised learning, in which you are learning yourself. This is the very simple example to understand. So if you are learning with yourself only, then it is a kind of unsupervised learning, means you are learning yourself, and on the basis of that you are predicting something, and you are doing certain, on the basis of that algorithm you are finding something. And supervised kind of the learning, where you are training your machine on the basis of your data, and from that you want to predict something. That is the case. So these are the two things, and these are the two types in supervised learning also. Yeah, machine learning is unsupervised. Machine learning is both kind of the thing. It is supervised also and unsupervised also. There are the two type of the algorithm you have to take. So both things it is needed basically. So now we have to understand, as the today's agenda, what is logistic regression. First you have to understand that I already tell you it is useful for the categorical kind of the data. So I hope so that you understand that what do you mean by the categorical kind of the data. It is just like classification kind of the data, might be a 0 or 1, or might be a true or false, or might be a just like yes or no, that kind of the things. So you are just like making a statistical classification model on the basis of that one, deals with the categorical dependent variable. And you have could be a binary kind of thing, 0 or 1, or could be multi nominal also, takes both continuous and discrete input data. So might be possible that you have a both kind of the data, and on the basis of that you are just like plotting that graph, and that graph will be putting on the basis of 0 and 1, and you are getting a S kind of the curve in that one. For understanding in a better way, just I am showing you one Excel file on which we are taking a very simple example for the logistic regression kind of thing, that you want to find out, you want to take the admission on the basis of your CGPA in a university, for example. So this is the example I have taken. I am just sharing that sheet to you also. So this is just like CPGA university. This is the rule for that one, that if your CGPA is greater than or equal to 7, then you will be eligible for the admission. So this greater than or equal to 7 means this is your threshold value. So your threshold value is 7. So you have to understand a new terminology. What do you mean by threshold value? Threshold value is a value on which you can have a chances of passes, you can say, just like chances of success, you can say. So there will be chances of success and there will be chances of failure. So there are a probabilities of two types, success and failure. On the basis of that you are finding something, and you are creating a graph on the basis of 0 and 1. So like that, here threshold value is 7. The meaning of that, just like we are giving some CGPA here for the different students, 2, 3, 4, 4, 5, 5, 6, 7, 7.5, 8, 8, 9, 9, like that. There is a huge data, but I am taking just small data from that one, and on the basis of my threshold value is 7. If it is equal to 7 or greater than 7, I give this to a 1, and rest of them to the 0. So it will be converted, means my complete data which is available, actual data, will be converted to the language of zeros and 1. And then on the basis of that one, I am plotting my graph. So it is just coming from the 0 and 1 like this kind of the S curve, and this is the complete data which is in the downside. If you see that these are the data which is I'm getting for the admission, 0, 0, 0, 0, 1, 1, 1, 1. And if I'm plotting this on a graph, so I'm getting this as a value 1, 2, 3, 4, 5, 7, and then after that it's going to the top one, and then 1, 1, 1, 1 we are getting. So this 7 is my threshold value here, and we are getting S kind of the curve here, just for understanding a very simple logistic model, that how we are just like converting our actual data to a just like yes no or true false kind of the things, are the 0 or 1 kind of thing. So like that, by the on the basis of my threshold value, I am converting my data to 1 and 0. That's the case. So this is just like we are converting our real data, which is the just like continuous data we are having, and then on the basis of that we are converting that data to categorical, and on the basis of that we are predicting something, or we are creating a model according to that one. Just for this is for your understanding. So let's understand that what the type of different kind of the learning. So if I'm just like just I want to explain you. This is machine learning. Machine learning is having two types of the things. One is supervised learning, another is unsupervised learning. In supervised learning, you are having a two type of the model, that is the algorithm for the regression and the classification. In regression, you are having linear regression also, and there will be a, in classification, if data is a classification kind of thing, then it will be a logistic regression. So this is the very simple model we are creating for that one. And just like why logistic regression, what is the need of that one? So tool for applied statistics to discrete the data analytics, like that, what is the giving outcomes in terms of the probability, means so like that might be possible on the basis of your data, if you are putting your dice is having 1 to 6, 1 to 6 and 2 dice, and just like if you are having that, what is the probability of getting 7? So you can find out that what is the probability of 7 on the, what are the success case and what are the failure case. In the terms of it is just like helping you to classifying the given data, you can say. So that's why the logistic regression is needed. Logistic regression is used when the dependent variable is the categorical, the meaning of that it is 0 or 1. The simple example for this is just like you want to find out whether your email is spam or not on the basis of certain parameters. So you are having certain kind of the words, and on those kind of the words you can find out my mail is spam or not, like that. Yeah, you can give this as a yes or no to 1 or 0 or true or false, that kind of thing. This is the simple example for this. Just like to understand this, where to use this logistic regression. So there I'm giving you the simple few applications in which we are using the logistic regression. Definitely when you learn in the detail, you can find out the much more on that one, and then definitely backend mathematics behind what the backend mathematics as far as the logistic regression is concerned, you can find out that also. So the another example is spam detection, where you are predicting that your mail is spam or not. This is very simple example. Another is credit card fraud, in which you are predicting a given card credit card transaction is fraud or not. In case of the marketing, you can find out, just like suppose there is an insurance domain. So in insurance domain, if you have a user, so you can find out that the user will buy insurance product or not on the basis of your data. And like that in banking also, you are predicting if a customer will be default on a loan, yes or no, true or false, that kind of the thing. Health also, you can predicting if the given mass of the tissues is beginning or the malignant, you can say. So there are a lot of example. On the basis of that your model, you are predicting something, and whether, and you are predicting basically probability of that one, and the probabilities depend on your basically top of the level, you can say threshold value. Just like you can assume that my threshold value is this one. So if it is greater than equal to your threshold value, that your case will be the true, and if it is less than that one, your case will be the false, like that. Yes or no, you are finding out as a result outcome. So these are the different assumptions in the logistic regression. Just when we are doing in practical approach, definitely that will be much better to understand, like that. These are the different points which I can explain you. Logistic regression does not assume a linear relationship between the dependent variable and the independent variable. So just like I'm giving you the example of the CGPA, we are just converting that linear regression kind of the data, means continuous data, to a binary kind of the data in 0 and 1 on the basis of the threshold value. Logistic regression assumes the linearity of independent variable and the log odds, and binary logistic regressions require the dependent variable to be the binary, like that. It is kind of 0 or 1. The independent variable need not be normally distributed. So definitely independent variable will be normally need not be a normally distributed. And the logistic regression requires the observation to independent each other. In other words, you can say the observation should not come from the repeated measurement of the matched data. So just like we are creating the different kind of the observation as in this example which I am showing you, and on the basis of this data also, even we are taking the repeated data itself also, but we are converting them also. Just like we can put how many times it will be coming, like that kind of the stuff we can do also. But for the plotting the graph for understanding purpose, we are just like creating this kind of the stuff, where you are just like finding out as far as the logistic regression is concerned. So then in this you have to understand the few terminology, that you have to understand confusion matrix in this also, and there will be a different terminology also. So just like confusion matrix, I am explaining you what do you mean by the confusion matrix. The confusion matrix shows the way in which your classification model is confused when it makes predictions. So when you are making a predictions on the basis of confusion matrix, you are finding out certain kind of the results, like that. Here just it is a simple in the last previous webinar I already explained that how this confusion matrix is created on the basis of your data. So just like it is creating on the basis of your true data, false data, or true false data, or false true data. So like that these are the just like giving for the example for the fire case, like that you can understand in better way that how we are creating a confusion matrix. Like that you have actual data which is saying your alarm is yes and alarm is no, like that. This is yes and no, and this is your predicted data where alarm is yes and the fire is no, fire is yes and fire is no. That is the case. So in on the basis of that, you are having a true positive case, means alarm is yes and fire is yes, then this is known as the true positive. When alarm is yes and your fire is no, then it is known as false positive. Then alarm is no and predicted means fire is yes, then it is a false negative. And there is no alarm and there is no fire, then it is a true negative kind of the case. So this is the meaning of that how you are building your confusion matrix. So this is you can say understand this. True positive means alarm goes on in case of fire. False positive means alarm goes on but no fire is there. false negative, no alarm in case of the fire, and the true negative, no alarm in no fire is there. So this is a kind of confusion matrix, and on the basis of that, suppose you are creating a data sheet on the basis of actual data, and you are having this kind of this things you are getting in your confusion matrix, like that. You are having 100, 25, 30, and 45. So 100, 25, 30, 45 is what? It is the data of the true positive and the false positive and the false negative and the true negative, while you are creating taking from the actual data. So actual data means when you are having actual data on the basis that is in your model, means that is your available in your actual data, and on the basis of actual data you are creating certain kind of the model. From that you are getting a predicted value. Just I will show you that how we are creating a model in R, so it will be much more clear to you as far as practical is concerned. And the backend mathematics, definitely I will tell you while you are going into the detail and while you are learning as a data science as a key, you can say your aim. So this is just we are assuming this. These are the thing in which you want to find out the what is your accuracy of your model. Like this in this case, what is the accuracy of your model? So you are getting this is true. This is the true yes yes. This is false, you can say, and this is true false, and this is false true, like that kind of the stuff you are having. So accuracy is true positive plus true negative divided by true positive plus true negative plus false positive and plus false negative. So this is 100 plus 45 in the top of the level divided by 100 plus 45 plus 30 plus 25, and you are getting 0.725 as a your accuracy, means 72.5% accuracy in your model, you can say, when you are converting to the percentage. So this is the one terminology where you are finding out the accuracy of your model. Then you have to find out the precision in your model also. What do the meaning of that one? What do you mean by precision? What the proportion of the positive identifications was actually correct. So this is known as precision. Precision means you have a true positive divided by the true positive plus false positive. That is the precision. So like that in this scenario, you are having 130 in this one, where 100 is the true positive, and this is your false positive. So you are taking true positive as 100 divided by 100 plus 30. So you are getting 0.76 as a precision, means the 76% is the precision in this model. Like that, there is another terminology, that is the recall, where you have to find out what the proportion of the actual positive was identified correctly. So in that case, you are having a true positive divided by true positive plus false negative. In this case, there is 100 in true positive and 25 in the false negative. So you have to be a recall is equal to 100 divided by 100 plus 25 is equal to 0.8, means 80%. So because as we have a limited time, so I'm going little bit fast for that one. But when we are doing in as an actual process, definitely I will tell you that how these things are coming and how we are going to calculate this on the basis of your actual data, and how we are finding out the things on according to the model. So this is to just for the understanding. And then just like thresholding, I already explained you that what do you mean by the thresholding. So again, I am just explaining on the basis of the my PPTs. So that is the logistic regression returns a probability, and we would like to convert this return probability into a binary value, that is the 0 and 1. So this is our logistic regression model, and on the basis of my threshold value when it is equal to 7, then I converted this on the 7 and onwards to 1, and the below that one I converted to the 0. So this I am creating just like the model as far as is concerned is that. So this is the threshold value. In this case, I am assuming as a 7 is my threshold value. So the data which is having greater than 7 or onwards, that will be I'm just giving to the 1, and that will be the taking the admission for your university. And if it is 0, then they will be the just like case of failure, you can say. These are the case of success, you can say. So there are the two type of the cases. One is success and another is the failure. On the basis of there, you have to find out the things. So this is just like the thresholding. So just like another example I'm giving, just like in the will it rain on the basis of your threshold value. So suppose you are having a threshold value, for example 0.7 or 0.65 right now, okay, and you are having a probability 0.73 you are getting on the basis of your model. So definitely you can say, because it is a greater than 0.65, so the result will be coming as a yes. So this logistic regression model will be giving you a result on the basis of your threshold value and the probability which you are taking, and the final you are getting as a result also. So you can find out that whether it is success or whether it is a failure, whether it is a true or whether it is a false or whether it is a 0 or 1, that kind of stuff. Like that is in the another example, there will be a probability is 0.59. So when you are having a probability of 59 means 59% probability and your threshold value is the 65%, so definitely it is lesser than that one. So there will be the result you are getting as a no in that case, because it will be the less than your threshold value. Like that in the example given already. So when the threshold value is less than 7, you can say, then they will not take the admission in the university. So all the data will be converted to the 0 in that case. When threshold value is 1, means that your data is greater than 7, your CGPA is greater than 7 onwards, then you are getting like that out of 10, because we are giving the CGPA out of 10. So you are getting this data 7.5 to 9.5 between right now, might be it is up to 10 also. So you are getting after 7, you are getting always 1 1 1 1 1. So this is the case where those peoples are the success and getting the admission in the university. These are the case on the basis of data you are getting. Now next, just like we want to just like understand that how we can create a model, so let's do it practically approach. So this is that how this logistic regression and confusion matrix will be created in our language. Okay, so in this I am taking a very simple example. Build a simple logistic regression model where the dependent variable is churn and the independent variable is monthly charges. So I am showing you the data also. I'm taking one example for the telecom industry data. So I am having a telecom data with me. There might be this. Okay, we can take directly that data. So we have a telecom data. I'm just opening that one. So this is the data of the telecom industry, in which they having a customer ID, gender. There will be a that senior citizen is yes or no or partner from the institutions, and then there will be a different kind of the churning. The meaning of churning means that the people will be just like taking the facility of your internet connection or the internet lease line from the telecom industry, and they are just like in your company means yes, and they are churning means no, means they are not churning, and if they are churning then there is a yes kind of the data. So they are churning from your company, they are leaving to your company and joining to taking the services from the other vendor. So this is the meaning of churning, that you have to find out the churning on the basis of your monthly charges or on the basis of your another things basically. So in this model what we are doing, we want to be building a simple logistic regression model where the dependent variable is churn and the independent variable is monthly charges. So just first you, in that case you have to install the R also. So I already installed this R, that you can download from the website directly, and then there will be a RStudio. You have to install this RStudio also. So I installed RStudio also in my. So let's do it practically. Building a logistic regression model from telecom data. So just see this data is available right now. It is in my F drive and it is in webinar folder. So first I set this to my working directory. That is the command for that is set wd. That is my set working directory. And just like in quotes, I can write here F column webinar. So if I write here get wd, so the meaning of this, you are getting your working directory. Now it is showing me F column webinar. So I am in the my working directory, and then I can have a command. I have want to read my this that is the CSV file of my, just like it is a CSV format, comma delimitated value. So I have to read this file in my data set, and it is having more than 7,000 rows in this one. Just I'm muting all the guys so there will be no disturbance. So what we are doing, we are reading this one. So read.csv is command for that one. And then if I am writing here my file name, so what is my file name? It is a telecom data. So just like I can just copy this name and I put this one, and the extension is CSV. So I write here the extension of this file, and this I am assigning to a variable. Say for example, I can assign this to, for example, data frame. So df1 is my variable. So this is my variable, and if I am writing here view and then df1, so this data will be coming to the memory of this one. Just like see here, the all the 7043 rows will be coming here, and 21 columns are there, 7043 entries are there, and this will be the customer id, gender, senior citizen, and then last one is the churn, like that kind of the data, which is your this data. So this is data will be coming at the top of the level, you can say. Start from your first field, that is customer id, and then gender and all these things. This will be coming to my R as a practical approach. So this is my first step I'm doing. So what I'm doing is I'm setting my working directory. So then I'm reading my that file, and then I'm assigning to as a variable, that is df1, because if I'm taking a very small variable to understand, then it will be good for the practice purpose, that how I'm using this kind of the stuff, and that is the case, you can say. So I hope so this will be as far as understanding is concerned, it is clear to you that what we are doing here. Now what we are doing, we are creating a logistic regression model. This is our main task, that building a logistic regression model from the telecom data. So for that, there is a command. That command is known as glm. So I can write here glm, and this will be the, basically if you want to, in the backend library, you have to install the package also, that is the ca tools it is required, and ggplot2 in the backend you can require. So you have to install this ggplot2 for the just like plotting the things, if you want to plot certain kind of the thing, and then ca tools if you want to install, then that is for the different kind of the linear regression model and the logistic regression model, and the other kind of the model also. Then that is the case, that you have to use the package that one and the library that one. So if I'm using lm here, then it is lm is used for the linear regression model, and glm is used for the logistic regression model. So in this glm I can write that how I am creating model. So this is my task given, that build a simple logistic regression model where the dependent variable is churn and independent variable is the monthly charge. So what I am doing here, I am taking the variable churn, this is my first variable, and second variable, so I use the tilde symbol here, and there will be a monthly charges. It is a case sensitive, so you have to take care that what are the variable name. So c is capital, so you have to write c is a capital, like that kind of the stuff. And the c, the monthly charges also, m is capital and c is capital, so you can take m is capital and the c is capital in that one. So this your model will be on the basis of you are creating a simple basically logistic regression model, where you are having churn and the monthly charges as your variable, and your data, then you have to write what the data you are using. So here you have to write your data is equal to, then definitely we are taking this as a df1, because our data will be coming, I am taking in a variable df1. So I directly write here data is equal to df1. That is the case. And after this, you have to write in a syntax, you have to write a family. So when you type fami, it will be automatically coming, and this is known as you have to write here in quotes binomial. Why we are writing this binomial? Because it is a categorical thing of things, 0 or 1, yes or no, or true or false, that kind of the thing. So this model will be my created, and this what I am doing is I am assigning this to a new variable. So what I am doing is I am doing this as a my log model uh, 1. So this is my variable I am giving log for the log for I am giving for the logistic, and model 1 is for my model name. So I am giving this log model 1, and this is I model I am creating this one. So this way I created the model, and just press enter here. So this model will be created, and after that if you write here, for example, there is a summary command. So you have to write summary, and if you are writing log model 1, so that will be converted to the object, and automatically it is coming, and when you press enter, you will get the complete detail for this one, that what you are getting. So this is just like call, this is GLM, that the formula you are using, this is on the basis of churn underscore monthly charges. These are the two variables, and family is binomial, and data is your df1. That is, df1 means your complete data which you are using in a as a variable in df1. And then there will be, it is automatically creating you for the deviance, residuals also, minimum also, first quarter also, median also, third quarter also, max also, the value of that one. And then it is creating you the coefficient also, and then it is giving you the just like this type of the variable, definitely that how it will be interpreted. So definitely when we go in the detail, I will explain you each and everything, this terminology. Right now our aim is that how we are creating this kind of the model and how we want to predict the things on the basis of model. So like that, suppose I want to predict something. So for that there is a command, you have to directly write predi, it will be automatically came here in predict on the basis of your model. So your model is that log model 1, and in log model 1 you have to write the data dot frame. So data dot frame will be directly, it is coming from your as a syntax, you can, if you choose from this one, and then this will be in data frame, you have to write what is your data frame. So that you have to write here monthly charges. For example, you want to find out if the monthly charges is equal to 50, then what is the probability of model, for example. So if I am writing here is equal to 50, and then after that I can write here, because I want to get a result. So here I write here type is equal to response, that you have to write as a syntax, and then you just like close this as a complete model. So this is just like a complete syntax for this one. What we are doing here, we are predicting something, and we are taking from our model which we are created already on the basis of this log model 1, which is the complete model which we are assigning to a variable. So this is my variable log model 1. So we are taking this log model 1, data dot frame, basically from the data frame is, this is my data frame on which, on the basis of that monthly charges is equal to 50, I want to find out what is the prediction. So just if I am pressing this as a enter here, and just you see that what the result you are getting on the basis of this one. So you are getting 0.2147944. The meaning of that, if your monthly charges is equal to 50, then 21% will be the ratio. 21.47% people will be churning from your company, because you want to find out that how many people will be churning in that case. That is the case, you have to find out that kind of the probability. Like that you can say, for example, in the second case, for example, if your monthly charges is equal to, for example, say 100, what is the response you are getting? So you are getting 37% will be like that. When your monthly charges is less, the prediction means the people are basically less people are the churning from your, that is the 21% only. When your monthly charges is 100, then there will be the probability of 37% people will be churning from your company. Like that you can find out, there is another option in which you can find out the multiple things in a one shot also. So here suppose I want to find out from, if my monthly charges is from, for example, from, it is starting with 40 and it is from the 40 to 70. So what is the probability I'm getting? So if I'm taking this 40 colon 70, it will give you a 31 kind of the result, like that. It is start from 40 and end to the 70. So it is giving you the each value 40, 41, 42, 43, 44, like that kind of the things that will be converted into the one means that is your first value, that is the value is taking as a 40 as a monthly charges, and in second it is taking 41, and last this is in 31, last value is the 70. So here you are getting a probability. When you are having a monthly charges 40, then your 18% is the probability. When you are having monthly charges, for example, 70, then it is a 27% probability. 69, then it is a 26.82% is the probability. Like that you are getting that kind of the stuff direct from your model. So that is the case basically. Now what we do, there is a, so this is the task which we have done, and we want to predict the values and build the confusion matrix to calculate the accuracy also. So this is the second case which we want to do, and we want to create a model according to that one, and then we want to create a confusion matrix also. So for creating a confusion matrix, what I am doing is I am taking a complete a different kind of the scenario in which we are creating a different kind of the model with the same data. So just like our next aim is, we want to calculate the confusion matrix, we want to create a confusion matrix. So what I am doing is, I am just uh, creating my there is a function is that function is sample dot split. CA tools, so package I'm installing this CA tools, or I can directly tell you that how to create that also. Then I have to use this library also. So this when I install this CA tools package, and after that I just use this library as a CA tools, it will be giving me sample data split. Previously it is not coming because I am not using that library. So I use this sample data split command here, and in sample data split what I am doing is, I can just like taking my data set, that is my df1, which is already taken my data. Just like if you not remember, so I can just again give this as a previous command. So this is my df1. So I'm taking this df1 on the sample dot split. So sample dot split, and then I'm taking my data, that is df1, on the basis of, if I'm putting dollar symbol, then it will give you my all the fields on the basis of churn. So I want to create a more splitting on the basis of churn. So this I'm use, and then I have to use my split ratio. There is a command sp, if you write split, so it will be automatically giving the meaning of this one. Suppose this is where you can say it is a kind of you are splitting your data onto train data and the test data. So what I am doing here, I am doing here 65% data I want to use as a train data, and 35% I want to use my test data. And on the basis of my training to the model, that is the machine learning kind concept, I want to predict certain thing on my I want to apply that on my test data, and I want to find out the related answer from that one, and I want to create the confusion matrix on the basis of that one. So what I'm doing is, I'm just giving this as a 0.65. So in this case, what is it is doing, it is doing that 65 data percent is converted to the true kind of the data, and this I am assigning to a variable tag one. So this is just like splitting this one, and I'm taking the subset of this one, subset of my df1, where my split tag, that is my tag one, is equal to you can say true. So you have to write here tag one is equal to true. The meaning of that, you are taking 65% data, which is just like converting to the true data, and this I am assigning as a my train data. So this I am giving as a train data. So just write here train, and then this is the subset of this one. So if you write here, for example, if you write here view train, for example, just for showing, so it is see that the whole data is 7043 rows and the 21 columns are there. When I write here view train, so you see that there will be 4 5 7 8 entries and 21 columns. So randomly it is picking the 65% rows from your data, and the rest of rows which will be remaining will be converted to the false kind of the data, and which we are assigning to a second subset, that is where my tag one is equal to false. So just like I'm using my subset here, subset, subset of what, subset of my df1, that is my data frame, where my tag one, that is equal to false. So I write here false, and this I am assigning to a my test data. So I write here test. So this will be, I just converted this to my test data and train data. So what I am doing is, I am splitting my data to 65 35 by this command, that is a sample dot split. After that I just like taking the subset of that one where my tag is true, and that I assign to train data, that is my 65% data. And then after that I'm creating a second subset, which is my tag one is equal to false, that is my test data. If I just I write here view, and if I write here test, So you can see that in train you are having 4, 5, 7, 8 rows, and in test you are having just like 35%, that is 2, 4, 6, 5 entries in this one. So this data will be converted, means your main data, that is df1, will be splitting to the two data. One is your train data and another is your test data. That way it is splitting. So this way we are just like creating it, means we are training our machine on the basis of our training data set, and that we are applying into the testing data set, and we can find out some certain things. Now we want to create a model. So definitely, as I already tell you that for logistic regression model you have to use the command glm. So here you write glm, and in glm you have to write on the basis of your churn and then monthly charges. So you have to write churn under tilt monthly charges, and here now the change is that one, your data is equal to, now it is train. So just like I am using my train data, and the rest syntax is the same which we have used previously also, that is the family is equal to, that will be the binomial. So you have to write binomial. So this will be, my model is created, and this I assign to my second model. So I write here log model 2. So I give the new variable name. So this is my second model which I am creating from my train data. So this model will be created, and after that I want to predict something. So what I write here, in this case I write here predict what, predict on the basis of my model. So what is my model? My model is log model 2 right now. So I can use my log model 2, and here my data is changed. What? Because whatever the training I am giving to my machine, on the basis of that training I want to apply that thing in my test data. So here I am my new data, I write here new data is equal to test. So this you have to write here, new data is equal to test, or you can also there is a syntax for that one, that is type is equal to, you have to write a response, because you want to find out that what is the outcome from that one. So in previous syntax, while you are creating a model, you have to write a family is equal to binomial, where the data is taking care for the your 0 or 1 kind of the thing, categorical data. And when you want to predict something, at that time you have to write a syntax type is equal to response. So that will be in code. So we have to write here response also. Even you can do, if you are having installed R and RStudio, you can do the same way in your machine also. So this way we are just like predicting, and this we just I'm for the understanding purpose, what I'm doing is I am just assigning this to my result. For example, this is log result. So I give the 2 because I'm creating a model 2 here, and I want to find out the result 2 here. So I just give assign this variable as a log2 result. So this is created, and after that I want to create a confusion matrix. Now next step is to creating a confusion matrix. Confusion matrix is created on the basis of your actual data and on the basis of your predicted data. So what is your actual data? Actual data is your churn, which is available in your test data. So this is your, we are taking this as a actual data for the churn. So what we are using here, we have to create a confusion matrix. For that you have to use the command table, and after table you want to take the test, this is your data, and dollar churn is your field. So this you have to take churn from this one. So this is your actual data. And what is your predicted data? Predicted data is nothing, it is your result which you are taking from your prediction. So you directly write here on the basis of this one, log result 2, it will be automatically came here. So you have to take log result 2 in this case. So, and also if you want to find out, just like you can assume that if greater than 30%, like that 0.3, for example log result is greater than 2.3 or zero point 0.4, you want to find out. So here you can just like the value of also, that is 0.3, you want to find out the confusion matrix on the basis of your 0.3%, that is the 30%. So when you are creating enter here, you can get this false data, true this is no and true, this is yes and false, and this is yes and true, like that kind of the matrix you are getting. So if you want to find out this what is the accuracy of that one, accuracy in model. So this is your 1142 plus 348 divided by 1142 plus 348 plus 306 plus 348. So this way you are getting your accuracy model. So you are getting 0.6949, means 69% accuracy is in your model which you are creating this one. So this way you are just like creating a logistic regression model on the basis of your data. You are applying that thing, the same thing, and you want to predict certain kind of the result. That is on the basis of that you are creating this
Uh,
one.
Hi Riti,
Yeah.
this is Vidya here. I just want to clarify one thing. Can you tell us, how did you calculate the accuracy?
Accuracy is basically total true and true and divided by the all of this. Just I can show you the slide so it will be much more clear. This is the accuracy. So this is your confusion metric. Okay. So this is accuracy is true positive plus true negative divided by all. This is the meaning of that: true positive plus true negative plus false positive plus false negative. Means of this, this is your true positive and this is true negative. So you are adding these two and you are adding these also. So what we have done here, the same way we are just like doing, we are adding this 1142 with 348. This is our top of the data, and then after that we are adding these 669 and 306 also. So divided by this one. So we are getting accuracy in model. I hope so it
Okay.
is clear that this meaning of this one. Even you can find out the precisions also by getting this TP divided by TP plus FP. And you can, if you want to find out the recall also, you can find out the recall also by giving TP divided by the TP plus FP, true positive divided by true positive plus false negative. That way you can find out. This way you can predict the things, and you have to create a model, and you can just like go ahead with this one and you have the answer. So like that, because we have a time limitation and it is just like the 1 hour demo only. Definitely when you are doing in the detail, definitely you learn a lot. You have to understand the basic concept and what the mathematics are the behind it, that how we are creating or how we are getting these predictions. So you have to understand that thing also. So I can explain by taking a few example in Excel. I will show you that this is your actual data and how the predicted data will be coming. So, because there is a algorithm written is already there. Algorithm is there. So on the basis of that algorithm, it is directly creating. In R, you are using the simple command. In one single command, you are creating a complete model for the logistic regression model. And on the second command, you are just like predicting the result also. And in third command, you are creating your confusion matrix, and on the basis of that, you are finding out the accuracy model. So this R language is very, very powerful as far as learning is concerned, and it is not requiring any kind of the programming background. If you are from any field like that, if you are from the simply BA or BCom students also, or if you from the engineering background, or from your statistical background, or you have MBA, or you have from the any background, and if you want to switch from any background to from the finance domain, you want to switch to the data science, you can immediately switch. If you are in e-commerce retail domain, you want to switch to the data science, immediately you can switch. So this is the biggest advantage because this is the very growing field right now, and you can see that it's the year 2019, and till next 10 years, this will be the huge scope in the data science. Every company will be just like migrating everything because the thing is depends on your data only. So that's the case. Yeah, lot of e-commerce industries are growing up, so definitely they have a very much they are very high requirement for the data scientists, because for the key features, for the small results, they want to find out the immediate things, and on the basis of that they want to predict the things, and on the basis of their model they are just like giving the result to immediate result also. So I suggest that hard code programmer is not required as far as because hard code programmer is required only for when you are creating algorithm kind of the things. But lot of algorithm means lot of packages is already available. More than 10,000 packages are already available for you to work. And then after that, if you want to use those kind of the packages, those kind of the algorithm, you are getting directly predictions on the basis of that one. That is the case. So thank you guys. Thank you once again.